Chapter number 17, Breathing and Exchange of Gases. As you have read earlier, oxygen O2 is utilized by the organism to indirectly break down simple molecules like glucose, amino acid, fatty acid, etc. to drive energy to perform various activities. Carbon dioxide CO2, which is harmful, is also released during the above catabolic reactions. It is therefore evident that O2 has to be continuously provided to the cell and CO2 produced by the cells have to be released out. This process of exchange of O2 from the atmosphere with CO2 produced by the cells is called breathing, commonly known as respiration. Place your hands on your chest. You can feel the chest moving up and down. You know that it is due to breathing. How do we breathe? The respiratory organs and the mechanism of breathing are described in the following section of this chapter. 17.1 Respiratory organ. Mechanism of breathing vary among different group of animal depending mainly on their habitats and level of organization. Lower invertebrates like sponges, coelenterate, flatworm, etc. exchange O2 with CO2 by simple diffusion over their entire body surface. Earthworms use their moist cuticle and insects have a network of tubes, tracheal tubes, to transport atmospheric air within the body. Special vascularized structure called gills, branchial respiration are used by most of the aquatic arthropods and molluscs, where vascularized bag called lungs, pulmonary respiration are used by the terrestrial forms for the exchange of gases. Among vertebrates, fishes use gills, whereas amphibians, reptiles, birds, and mammals respire through lungs. Amphibians like frog can respire through their moist skin, cutaneous respiration also. 17.1.1 Human respiratory system. We have a pair of external nostrils opening out above the upper lips. It leads to a nasal chamber through the nasal passage. The nasal chamber opens into the pharynx, a portion of which is the common passage for food and air. The pharynx opens through the larynx region into trachea. Larynx is a cartilaginous box which helps in sound production and hence called the sound box. During swallowing, glottis can be covered by a thin elastic cartilaginous flap called epiglottis to prevent the entry of food into the larynx. Trachea is a straight tube extending up to the mid-thoracic cavity which divides at the level of fifth thoracic vertebra into a right and left primary bronchi. Each bronchi undergoes repeated division to form the secondary and tertiary bronchi and bronchioles, ending up in a very thin terminal bronchioles. The trachea, primary, secondary, and tertiary bronchi and initially bronchioles are supported by incomplete cartilaginous ring. Each terminal bronchioles gives rise to a number of very thin, irregular walled and vascularized bag-like structures called alveoli. The branching network of bronchi, bronchioles, and alveoli comprise the lung. Figure 17.1. We have two lungs which are covered by a double layered pleura with pleural fluid between them. It reduces friction on the lung surface. The outer pleural membrane is in close contact with the thoracic lining, whereas the inner pleural membrane is in contact with the lung surface. The part starting with the external nostrils up to the terminal bronchioles consists the conducting part, where the alveoli and that duct from the respiratory or exchange part of the respiratory system. The conducting part transports the atmospheric air to alveoli, clears it from fusion particles, humidifies and also bring the air to body temperature. Exchange part is the site of actual diffusion of O2 and CO2 between blood and atmospheric air. The lungs are situated in the thoracic chamber, which is anatomically an airtight chamber. The thoracic chamber is formed dorsally by the vertebral column, ventrally by the sternum, laterally by the ribs, and on the lower side by the dome-shaped diaphragm. The anatomical setup of lungs in a thorax is such that any change in the volume of the thoracic cavity will be reflected in the lung pulmonary cavity. Such an arrangement is essential for breathing as we cannot directly alter the pulmonary volume. Respiration involves the following step. Number 1. Breathing or pulmonary ventilation, by which atmospheric air is drawn and CO2 rich alveolar air is released out. Number 2. Diffusion of gases O2 and CO2 across the alveolar membrane. Number 3. Transport of gases by the blood. Number 4. Diffusion of O2 and CO2 between blood and tissues. Number 5. Utilization of O2 by the cells for catabolic reactions and resultant release of CO2. Cellular respiration as detailed in the chapter 14.